Hi, this is my second video about the normal distribution, and this video I want to talk to you about the standard normal distribution Z. What do we mean by the standard normal distribution Z? Well, first of all, my last video I ended with this. This was a normal distribution using X to represent a continuous random variable, and we looked at probability of X is greater than 8, greater than 8.2 and so on. Now, what is Z about? Well, if you just look at this is one particular case for a set of data. Now, choosing any particular data set, you're going to have a completely different value of mu every single time, aren't you? It's more likely we look at heights of different people across different countries, you'll get a different value of mu. Then you look at weights of different people in different situations, you'll get a different value of mu. Always, you're going to end up with a different sort of set of axes because you're going to label them these different, okay? Now that is for when you've got a particular case, and that is when you've got X. When we talk about standard normal distribution Z, we are looking at effectively standardizing our probabilities and standardizing our means so that we always talk about a mean having the same value, okay? If you can standardize the data in such a way so the mean is always a specific value, then it just makes it so much easier for us to deal with, okay? So let me just example of how that works. Okay, so what we're going to do is we're going to standardize this normal curve and get it to fit this, and we can do that with any data set, okay? With any normal distribution we can actually do that. I'll show you how that works, okay? Now, if I just take this data set here and I've got 8 as being the mean value, if I subtract 8 from that, then I'm going to rewrite those, aren't I, okay? I'm going to rewrite those, and instead of 8, I'm going to have 0 there, and if I subtract 8 from all of those numbers, I'm going to have 0.2, 0.4, 0.6, and then likewise, if I keep on subtracting 8, that's going to be negative 0.2, negative 0.4, negative 0.6. Now what I'm going to do is I'm going to divide by the standard deviation. Remember, the standard deviation for this was 0.2. So if I divide all these by the standard deviations, what am I going to get? I'm going to get 1, 2, 3 there. And I'm going to get negative 1, negative 2, negative 3 there, okay? And that is what we call the Z distribution. Let me just show you the formula so you can see how it works. So for a normal distribution, if you just subtract the mean value, so subtract mu, and then divide by the standard deviation sigma, you'll end up with what's called the Z distribution. And the Z distribution is this. So for X, we write it's normally distributed with mean mu and variance sigma squared. With the Z distribution, it's written as Z is normally distributed with mean 0, and notice the standard deviation and variance are both 1. What that allows us to do is to draw a graph like this for any set of data. Okay? For any set of data, we can always have 0 as being the mean, and then 1, 2, 3, negative 1, negative 2, negative 3, which is very convenient if you think about it. If we have a mean of 0, then any positive value will be above the mean, any negative value will be below the mean, and it's quick and easy to see 1, 2, 3 standard deviations above or below. And what we can use is we can use a standardized table of probabilities to work out whatever it is we need, okay? And I'm going to talk you through that in a minute, okay? But we can work out what the probability of you having a particular range of values, or a probability of being up to a particular value or greater than a value, using our standard table of probabilities, okay? Which is really, really useful. So the Z distribution is something that we're going to be finding extremely helpful in this unit, okay? Okay, now I want to talk to you about how to use the tables to find probabilities. This is probably the most crucial part of this unit, the normal distribution, okay? First of all, I'm going to show you a screenshot of what the tables look like. Here it is. So it looks rather scary, doesn't it, the first time you see it? What is all that about? What are all these numbers? Well, let's just come back to me. So here we are. So what that table showed you was a series of numbers for Z ranging from 0 to 4, okay? So you've got numbers 0 up to number 4. So the 0 is there, which of course is the mean, and 4 is just some notional value that's way bigger than 3. Remember we talked about, you know, over 99% of the population being within 3 standard deviations of the mean. Well, 4 is enough, okay? 4 is enough. So we've got tables ranging from 0 to 4. Now, how do the tables actually work? Well, if you notice, there are two columns, okay? There are two columns for the table, and for the value of z, it gave you this result here called phi of z was 0.5. How do we interpret that? What it's saying is that the probability of having a value up to 0 is 0.5, which makes sense, I hope, because all of this is 1. The entire probability of everything on the curve is 1. So if you're looking for a value up to 0, then it's going to be 0.5. For the moment, don't worry about whether it's up to or up to and including, okay? What the tables show you is the probability of z being a value up to a particular given value of a, okay? Doesn't matter if it's less than or equal to, it is pretty much the same thing, okay? Remember I told you the probability of z being a particular value itself, so the probability of z being a is actually 0, therefore it makes no difference whether z is equal to, less than or equal to, or less than, okay? Let me just show you the table again. Okay, here you are. So you can see the first entry is when z is 0, then phi of z, the probability is 0.5. So come back to the board again. So what we're given is, we're given a list of probabilities from 0 up to 4. So in other words, let me just choose another one, 1.54. So I'm just reading my notes there. So if we're looking for a probability of z is less than 1.54, let me just write it in here. Okay, probability of z is less than, whoa, didn't mean that to happen, less than 1.54. Let me just show you the part of the table I'm looking at. So remember I said that you effectively got two columns. Well, because you can't fit all the numbers from 0 to 4 on, they've been split across the page, so to speak. So highlighted, you can see when z is 1.54, and then we're looking at phi of z, we want to read off what that value is. It is 0.9382, isn't it? 0.9832. So just cut back to me then. So 0.9832. So what we're saying is 1.54 is approximately here, isn't it? Okay, there is 1.54. This figure of 0.9832 is the probability of you having a value up to and including 1.54 or up to 1.54. Remember, the less than or less than equal sign doesn't really matter. So the probability of all of that is 0.9832. Okay, that's how the tables work. All right. Let me give you another example. So now I'm showing you the tables again, but this time I've highlighted when z is 2.65, okay? When z is 2.65. Then phi of z, so the probability of a value being up to 2.65 is 0.9960, okay? So notice how all the values in the table give you a rounded probability to 4 decimal places. Right, so if I just come back to me again. So here we go. So what that tells them is that the probability of z is less than 2.65 is that value there, so 0.9960. So if I were just to estimate where that is, so around about there, say, that's 2.65. What that means is the probability of a value up to 2.65 is 0.9960. And that's how the tables work. That's how the tables work. You just need to know the value that you're looking up towards, and then it's always from left to right. It's the probability of an amount up to a particular value. That's what the tables are doing, okay? You might have noticed, so I'm just going to stick this in because this is calculus, okay? You might have noticed this lovely looking integral at the top of the formula sheet. If you didn't, then here's the formula sheet again. There we go. What's that integral doing there? Well, this is actually a formula for the curve, okay? A curve has got a mathematical equation, here it is, and if you've done integration to find areas bounded by curves, you'll realise what this means. It's saying that the area between negative infinity and a particular value of z is given by, and then in this case here, okay? So from the left, the far left, from negative infinity up to a particular value, where z in this case is 2.65, the area of that is 0.9960. So basically that's what the formula is there for. It's telling you that for each value of z specified in the table, the area up to, from negative infinity up to that value of z, is given by the actual table, okay? I do love this integral, I really do love this integral. I'm going to say this again, I mentioned this in one of my earlier integrals, earlier videos. if you're interested in that integral, then look up the video where I talk you through that. It's integral e to the negative x squared, okay? You can see how it's similar. Ooh, it's similar to that one, except that's half. Don't worry about the half. That's t, okay? It doesn't matter which variable you use, because basically we're integrating with respect to t. And don't worry about that either, because that's just a constant value, okay? This is the integral I'm looking at. Once you get to the end of that 30-minute presentation, which you'll probably re-watch lots of it again and again and again, then you'll understand why the entire area of this curve is 1. Okay. Right, let's just move on a little bit. Suppose instead you need to find the probability that z is greater than a particular value. Okay, I'm sorry for that buzzing, that's my light. There, just give it a touch and it stops buzzing. Okay. Suppose you want a value that's greater. Well, the tables only give you a probability up to an amount. So how about you find a probability afterwards? We use the symmetry of the curve to do it. So in this case, we're looking at that. I've just shaded it in. Sometimes it's useful to have a diagram with the shaded part in. It helps me, it might help you to visualize what area you're looking for. Remember, with this chapter, you've got to associate area with probability. Okay. So how would you find that? We use the symmetry of the curve, okay? We use the symmetry of the curve and the fact that the whole area adds up to 1. We've worked out that the probability of this bit, let me just put an arrow, all of that is 0.9960. So therefore, this bit in here must be the difference between 0.9960 and 1, because all of that probability has to add up to 1. So that will be 0.0040. I'm not going to put the 0 on the end. So that would be 0.0040. Now I mentioned using symmetry of the curve. Well, I've got another example to show you. Just hang on a minute while I clean up my board. Okay, so here we go. This is an example where we're going to have to use the symmetry of the curve to actually solve this problem. We want to work out the probability of z is less than negative 0.75. Right, let's have a look at the table, shall we? Right, here we go. Can you see our immediate problem? There is no value for z is negative 0.75. In fact, there are no values for when z is negative at all. So how do we do this? The tables only give us values for z is 0 onwards. How do we find a probability when z is less than 0? This is what we do. We use the symmetry, okay? Let's ignore that for the moment. Let's look at the modulus of negative 0.75. Let's look at instead the probability of z is less than 0.75. The reason we're going to do that is because we can find the probability of z is less than a positive value. So we're going to use the table instead to find that, because we can actually do that. Here it is. So if you look at the table there, I've highlighted z is 0.75 and we've got a probability of 0.7734. So I'm going to write that down, 0.7734. And then I'm going to draw my diagram what we've actually found, okay? So 0.75 is about here, okay? 0.75, and I'm going to draw a line, remembering that this is the probability of everything up to 0.75. I'm not going to do the shading here, I'm just going to highlight that bit there, is 0.7734, okay? So what that means is, this bit here, I'm going to shade that bit in. This bit here has got to be the difference between that and 1, hasn't it? So that's going to be 0.2266. Okay? So I found the probability of z is greater than 0.75 is 0.2266. Right, now I don't need this anymore, so I'm just going to rub it off. This is why I didn't shade this bit. What we actually want, of course, is the probability z is less than negative 0.75. So I'm just put that in. So there is negative 0.75. Okay. What we want is the probability of all of this shaded area here. Can you see it's exactly the same as that shaded area there? That's how we use the symmetry. The probability that z is less than negative 0.75 is the same as the probability of x is greater than 0.75. And that's how we use the symmetry. In terms of our working, what we would do is this. We'd write down probability Z is less than negative 0.75 is 1 subtract 0.7734. Because remember, that's how we worked it out. We got all of that was 0.7734. Subtract that from 1 to get this amount, and by symmetry, that is our answer. So 0.2266. Okay? Right, in this example, I'm going to show you how to work out the probability that Z is in between two specific values, okay? Now I've chosen these values on purpose because if you remember before, we have worked something out involving 1.54 and 2.65. Maybe just pause the video and use that information to try and see if you can work it out. Well, earlier we looked at the probability of Z is up to 2.65, okay? We got the probability of all of that was, let me see it again, 0.9960, okay? So we've got the probability of all of that was 0.9960. So I can't remember these numbers, so I'm just reading off the board in front of me, okay? And I'm just going to write that down. So probability Z is less than 2.65 was 0.9960. And also we worked out probability of Z is less than 1.54. So let me just get rid of that arrow, okay? And 1.54 is about there. We worked out the probability of this bit in there, and that bit was 9382. Just check I've written, yes, 9382. So we write that in. We had Z less than 1.54. Probability of that is 0.9382. And what we want to do is just get the probability of this region there, the area of that shaded region, okay? How do we do it? It's quite easy, okay? It's quite easy. We know up to there it is 0.9960. Up to there it is 0.9382. Therefore, you find the difference. You do all of that, subtract all of that, okay? So the answer to our question is going to be 0.9960 subtract 0.9382, and then we're done. And that gives us 0.0, let me just check, 578. Yes, I worked out earlier just to save a bit of time on that one. So 0.0578. So even though I used the examples I did earlier, just bear in mind what you'd have to go through in order to work out the probability that Z is between two different values, okay? Right, my last example for you, it's find the probability that Z lies between these two values, negative 1.20 and 1.40. So I made it a little bit challenging because obviously you've got a negative value there and then you've got a range of values. Maybe just pause the video and see if you can have a go. Done that? Okay. I have to admit, okay, I do like doing this sort of thing. It's no big secret that I do not really like statistics and probability. I'm sorry if that's the first time you're hearing this. I have mentioned it before in my other videos, but no, it's not really my thing, okay? Of course, it beats, hands down, every other non-mathematical subject. But in terms of the whole mathematical arena, shall we speak, it's got nothing on pure maths or mechanics or algebra or calculus and that sort of thing. But yeah, there we go. But I do like doing this, okay? There's some sort of nice problem solving element to it as well. Maybe it's the link that I'm always thinking about between this and area under a curve, which is integral calculus. I do love integral calculus. That has got to be one of my top mathematical topics, okay? Integration, yes, I love integration, okay? Maybe it's because of that, okay? But for some reason, I do like doing this stuff, okay? Anyway, hopefully you've had a go at it. What I'm going to look at first of all is the probability of Z is less than 1.40. Okay, we can do that. So 1.40 is about here, yeah? And what I'm going to do is look at the probability of everything is up to 1.40. So on the table, here's the screenshot of it. So I've highlighted 1.40 for Z, and you've got the probability is 0.9192. So I'm going to write that down, 0.9192. So that's the probability that Z is less than 1.40. Okay, so that's the first easy bit done. Okay, right, next, the negative value. That's awkward, but remember what I said you need to do? You need to consider the probability of Z is less than the modulus of that. Take the positive value, okay? Work out what that is. Probability of Z is less than 1.20. Okay, so here's the table again. You'll notice I've also highlighted Z is 1.20, and the probability of Z is less than 1.20 you can see as 0.8849. So I've just written that down here, and what that means is, if I just draw a representation, that means that this probability here, okay, I'm not going to shade it in, I'm just going to highlight it, is 0.8849, so it's everything up to 1.20, and so the probability that Z is greater than 1.20, this bit there, will be the difference between that and 1. So that is going to be 0.1151, alright? And if I just get rid of that now, and this, we don't quite need that, sorry for the mess, it's not very tidy, is it? Let's just use my proper rubber for that. So by symmetry then, negative 1.20 is about here. Let's just try and get the symmetry right, shall we? There we are. So what we found is the probability of that bit, okay, is 0.1151. So let's write that down. Probability of Z is less than negative 1.20 is equal to 0.1151. I probably don't really need to have that anymore, but I'm going to leave it there anyway. Okay. Right, let's just rewrite this, 0.1151. Let's just get rid of that. Okay, and then let's just put this back again, 1.40. There it was. All right. And yeah, what we're wanting, of course, is all of this. Okay, if I just unshade that, okay, and put the arrow there, we just want all of this. Okay, that's the bit we're after. We can do that now because the probability up to 1.40 is that 0.9192, and the probability up to here is that 0.1151. So that means our answer has got to be the difference between the two. Okay. So 0.9192 subtract 0.1151 will do for us, okay? And that is 0.8401, okay? And then we're done, okay? I'm hoping that, well, not only did you understand it, but I'm hoping you enjoyed it as well. Best thing to do is just to practice some questions on your own. Find a set of questions somewhere and then just practice by using the tables. That's what this bit is about, really. How to use the tables to find various probabilities such as these. Okay. I hope you enjoyed that. I'll see you again.